what does it mean to be a programmer? And what does it mean to be someone that writes code? Well, in this short little tutorial, I'm going to introduce the idea of coding to you and talk about how a computer is able to follow instructions and carry them out, and the ways in which we, as programmers, can think about how to provide instructions to the computer that it can follow. So the first thing I've done here is I've imported a turtle. Now my turtle is a little friend that can follow instructions. I've given him a name, T. I could call him Jimmy if I wanted, and then I could give Jimmy instructions. But I've decided to call him T as it's quicker to write. So here I've given Jimmy an instruction to go forward, and then I've asked him to wait or only exit once I've clicked. We're now going to ask the Python programming language, so the Python interpreter, to execute this file, which is actually called example.py. And we'll see that firstly, our turtle has gone forward, and then he's going to wait until I click to exit. And we can give our turtle lots of types of instructions, so I can tell him to turn right. And if you remember your simple geometry at school, or if you're at school currently, we can know that 90 is the degrees in a right angle, so we've gone forward by 100 little turtle steps, and then we've turned 90 degrees to the right. Now I can ask my turtle to do this 4 times, and we should be able to draw a square. Now that I've defined how to draw a square, I'm going to actually put this in a function definition called square. And instead of just going forward by 100, we're going to pass in this additional piece of information, which is the size. Now when I run this code, you'll see that nothing happens. We just wait to exit on click, because I've defined the instructions for drawing a square here, but I haven't actually asked it to do so. So I'm going to ask it to draw a square of size 100, and he will draw a square of size 100. But now I can ask him to just draw a square of lots of different sizes. So I can say 50, we can do 70, we can do 10, and it will follow each of those instructions one at a time. And we could even put our instruction to draw a square in a loop. So we can say for I in range, starting at 10, going up to 110 with increases of 10, we want to draw a square of size I, and that should say start at 10 and then draw a square of size 10, 20, 30, 40, all the way up to 100. So our turtle is able to learn and follow instructions, but actually we're the ones that need to think about what those instructions need to look like. So let's add some additional information into here. We're going to pass in something called X and Y, and now before we actually draw our square, we're going to pick the pen up, so we're not going to draw. Think about a pen on a piece of paper. We're then going to go to our X, Y position, and then we're going to put our pen back down. And after we've done that, we're then going to draw our square, and this should allow me to draw a square in any position on the screen that I want. So if I pass in -100, 100, and a size of 10, we should be able to move to a particular position and draw a square. And now we can draw squares in lots of positions. Let's draw another one over to this side of the screen. Okay, now I actually don't want my turtle to do the drawing. I just want the square to appear like magic in a single frame. So what I'm going to do is I'm going to disable the tracer. The tracer is the thing that actually does the drawing. And I'm also going to say hide turtle. Now when I hide the turtle, what that's going to do is it's going to stop my turtle's arrow from actually appearing. We're then going to still wait for our exit on click, but what we're going to do is before that we're going to say update, because what this will do now is we've disabled the tracer. It won't actually draw anything on the screen until I've done my drawing, and then I call update. So let's do that, and you can see that our squares just appear. Now the final thing I'm going to add into this before we look at creating animation is going to be color. So we're going to add another parameter into our function called color. And before we start drawing, I'm going to say t.color. We're going to set to our chosen color. And then before we start drawing, I'm going to say begin fill. We're going to draw our square, and then once our square is drawn, we're going to say end fill. And now we should be able to pass in a chosen color to our square function, and now we can draw a square. And we can fill it in to make it red. I'm going to make my square a little bit bigger. And now what we're actually going to do is we're going to get our square to move. So instead of having our square just drawn once, we're going to put it inside of a loop. Okay? And inside this loop, we're not going to need our exit anymore because this is going to always run. So this is a game loop. It's called an infinite loop. I won't go into detail about that now, but this is essentially going to keep drawing our square again and again. But we also want our square to move. So I'm going to store a X position like that. And what we're going to do is every time that we draw our square, we're going to draw it at its X position. Oops. I'm going to draw it at its X position. I'm then going to increase its X position. And we're also going to import a function called sleep. Now, this isn't necessarily needed, but what I'm going to do is every time we draw our screen, I'm going to ask our computer to sleep for a really short amount of time, because that actually gives us enough time to see the square before it moves. I'll show you what happens when we get rid of that. Okay, so now if we run this, you'll see that we're going to create a smudge across the screen because we keep drawing the square, but we're not removing the old one. So every time I draw my square, before I draw it, I'm going to ask the screen to clear. And now we've got an animated moving square. Now, in order for us to see what, well, let's just quickly take a look. What happens if I comment this out? So that's no longer there, okay? So we're going to run it, and you see it's much faster. And if we add our sleep back in, it will run a little bit slower and a little bit more steadily. And as we increase this, we increase the time between frames, and we wait longer before drawing the next one, so it slows it down. Okay, so this is a really simple Python script that we can use our turtle to actually create animation. Now, I have my own game library that I built using this called tphysics, and we're going to take a little look at how that works now. So I'm going to say from tphysics, which we can see is stored here. From tphysics import star, which means import everything. And we're going to create a new game, and we're going to call it example game. And we're going to give it a background color of light blue. And yeah, I think that should be all right. And now we're going to create what's called a game loop. And every time that our game loop runs, we're going to ask our game to update. We should just have a... If we now run this, we've got an example game, and it's got a light blue background. Now, in order to add something to this game, we're going to say create a player, which is going to be a rectangle. We're going to create it at position 0, 0, with a width of 50, a width of 20, a height of 50, and we can give it a color, let's say yellow. Now, when we run this, nothing actually happens, because before we can get it to appear, we need to add the shape to our game. So we're going to add it to the game. And there we go. Now, in order for us to do something with this, we're going to want to detect some key presses. So we're going to say if game.isPressed, and we're going to check for the up key. And if we detect that the up key is currently being pressed, we're going to take the player's Y location, and we're just going to add 1 to it. So now when I hold the up key, our player will move up. We can then use this and copy and paste it to do our down. By reducing our Y, we can go to the right if we increase our X, and if we decrease our X, we can move to the left. So when we're pressing up, increase the Y position. When we're pressing down, decrease the Y position. When we're pressing right, increase the X position. When we're pressing left, decrease the X position. And now we have the ability to move our player. Now I'm going to actually make him a little bit smaller, and instead of moving by this constant speed, we're actually going to set up a variable called player speed, and we're going to set it to 1, and this will allow us to increase the speed of the player over time. So let's do that. So now when we run it, we can get our player to move, and then the last thing we're going to do is we're going to create a new addition to the game, which is going to be a circle, and it's going to spawn at a random position. So we're going to want to call from random import random int. My random integer can generate a random number for me, so I'm going to give this circle a random position between -250 and 250. on its x. I'm going to give it a random position of between minus 250 to 250 on its y. I'm going to give it a radius of, let's call it 5, and we're going to make it purple. We need to add that to the game, and we should now see that we're able to spawn a pickup. So we now want to just check if we touch the pickup. So we're going to say if the player collides with the pickup, then we want to take the player speed and we want to add 1 to it. We also want to generate a new random position for the pickup. So I'm going to generate its x position and its y position as a random number. And now we should see that whenever I pick this up, my speed increases by 1. So the last thing we're going to quickly add in is we're going to add a score. So I'm going to say score equals 0, and whenever we pick up, we're also going to increase our score. And every time that we draw a frame, we're going to say game.write, and we're going to draw this at the top left hand corner. So we're going to say minus 250, 250. We're going to write our text of a formatted string called score, and we're going to say our score is, and then we're going to insert or format our score variable into here. We're going to give it a black color, and we're going to give it a size of 20. So now you can see that every time I pick one up, my score is going to increase, or at least it should. I've said score equals 1, whereas it should have been score equals score plus 1. So now whenever we hit our pickup, my score is going to increase. And as you can see, what we learned earlier about rendering, that's all that's happening here. I'm controlling, using the turtle, I'm drawing a square, but I'm doing it without tracing it. And every frame, I redraw it. And all we've done is we've written a game library, which has some pre-built functions into it, things like collide, which checks if we're colliding between a square and a circle, or a rectangle, or whether a point is in another. And then we've also got some rendering functions. Whenever we call our update, what we do is we run through all the shapes in our game and we draw them. We go through all the text in our game and we draw it. We update. So underneath, we are doing all of our rendering using Turtle, but we're using the game engine tphysics. We've added in a lot of pre-built functions that makes it really easy for us to create shapes, draw them, move them around, check for collisions. I hope you've enjoyed this introduction. I've tried to keep it as short as possible. And yeah, please have fun using tphysics. Let me know if you have any feedback, and I will be continuing development through next year. Thank you.